In the second reading for the first week, we get to look a little bit at the history of the field. And I know that studying the history of a problem or a scientific field is often a tedious activity. But the history that we will see in this chapter is very recent. So I encourage you to try to understand what happened in these decades before we got to the artificial intelligence that we have today. And the reason is because it's going to be very useful for you, especially later on when we're thinking about current capabilities. What can AI models do? Why could these things be dangerous? Would AI models ever be able to do thinking? And yeah, questions about machine cognition and trying to think about the future of AI and how this technology could be dangerous or how it could be compared to human cognition. It's very useful to have some examples, and because this is recent history, it's very helpful to be able to draw on some of the examples from the recent past of this technology. So what you see in this chapter is first, how do we get to where we are right now. You see a few things about, in general, long-term history of the world, and then the first thing is, okay, machines seem to be doing certain things. We seem to be doing information processing with machines in the 1940s. You may have heard of Alan Turing and the Enigma, right? So there is some kind of AI technology at the time. However, this is very much far away and technically different from what machine learning and deep neural nets do right now. But it's good to have a sense of how there's AI even in the 1940s, right? It looks very different. It does different things. But these ideas that, okay, we may have intelligent machines, or what's gonna happen if we have human level intelligence machines, or even super intelligent machines. As you know, the title of the book that this chapter is from is called Super Intelligence, right? So these are ideas go back to the 1940s, and so they're not really something that people just started thinking about very recently, like since the deep learning revolution, if you want to say, since 2015. Here's the story for what we have right now, which is the deep neural networks. So in 1956, 10 scientists meet at Dartmouth College. They hold a workshop there. And John McCarthy coins the term artificial intelligence. So before that, nobody used that term. Before John McCarthy said artificial intelligence, used this term. And then you see here how we have different models that can invent logical proofs, right? They're able to do some kind of thinking. Remember from Aristotle earlier, syllogisms, right? Deduction, induction. So there are some systems that can do some kind of problem solving. And then later on, you might have heard of this program, ELIZA, that can impersonate a psychotherapist, right? So there are signs that this thing that we call AI, that might work, that might do very interesting things, that assimilate human cognition, right? This is interesting. So you get to read more details on that here. And what another thing you'll notice is that we get a lot of AI winters, as they're called in AI. in the history of the field, where for some period of time, AI falls out of fashion, right? What you see here. There is a period where AI doesn't really work for certain reasons. People aren't really interested. Usually there's some technical limitations that cause this winter, either some kind of memory capacity problems, processor speeds, usually maybe data scarcity. There's something that goes wrong, and just scientists lose interest at the time. It's not the main thing they're interested in. And then again in the 1980s, the interest in artificial intelligence starts to grow again, as you see here. And again, we get another AI winter, right? There's another reason, again, technically, to not think that AI is worth investing a lot in. So at the time, we don't have neural networks except for the idea of machine learning and deep neural networks not exists at the time that these scientists meet at Dartmouth. But what usually people mean when they say AI is the good old-fashioned artificial intelligence, which is very heavy mathematically. It utilizes symbolic logic, symbolic systems are they're called, and that's usually what people mean by AI, good old-fashioned AI. And so here what you see is people knew about neural networks, but they're not deep neural networks, right? So the idea that you can have a neural network, you'll see in the next chapter, in the next week, a video. What is a neural network? Highly recommend to watch this video and try to really understand what's the structure of a neural network. At the time, they introduced an algorithm. It's called backpropagation, and this makes a neural network more complex. What does this mean? It's now a multi-layered neural network. It's not just one layer. So this makes it very, very much more capable than it was before. And what's philosophically interesting here, and interesting as well from a perspective of psychology, is that here's an approach to how minds work, right? Connectionism. That means that the brain has all these connections, and if you want to generate something that will be as capable as a human brain, what you have to do is to find what these connections are and try to replicate them. So at the time, good old-fashioned AI doesn't really make a lot of progress, and this new ism, as Bostrom says, connectionism, starts to become something that's worth working on at the time. Parallel subsymbolic processing, and a lot of effort is put into how can you make artificial neural networks work and do more and more impressive things. And that's all thanks to this algorithm of backpropagation. So this is, we could say, the beginning of what we have now. Connectionism works, apparently. You get systems that are powerful and they can do deep neural networks work. They're deep because they have all these hidden layers. It's not just input, output, and one layer and nothing happens. There are many layers. Something happens in these layers, right? What does it happen exactly? We can you'll see later on. There's very often there's a black box of neural networks, but it's not it's not exactly a black box. We can say some things. And so this thing becomes more and more powerful. Another kind of algorithms here, the evolution-based methods, genetic algorithms, also gives more hope that AI could work. And that's the end of the second AI winter here. So we are in the 90s. That's why I said this is a recent history. So it's worth understanding the trajectory of the technology and what brought us here. And here you can read about a Bayesian, what is a Bayesian agent. We talked a little bit about what is an agent in the previous video. This is a more formalized, more refined approach. What do we mean by an optimal Bayesian agent? If you don't know some of the details here, try to look them up, but don't worry too much about it. The important thing is to know some of the terms, and if you can give a definition, or if you can understand approximately what we mean and what happens, what is optimality, what is Bayesian, what is a Bayesian agent, this is pretty good. I wouldn't worry too much about it. Just make sure you are somewhat familiar with the vocabulary that is used here. And the rest of the chapter mentions different kinds of AI that we have now. This is not the most updated one, as you will see. It doesn't mention large language models, so it's up to 2012. Because this book is not the most recent book, but it's very it's a little bit outdated, but it's still very helpful in kind of getting an introduction to what these things are about. And in the last part of the chapter, you get to read a little bit about future speculations, let's say, about machine intelligence, which has also been one of the interests of AI scientists, and especially the question of when are we going to get human level machine intelligence. And as you'll see, this is often defined as AGI, artificial general intelligence. And it's worth taking a moment to think, from what you've read so far, what's your guess? Do you think we might be very far away from it? Do you think we might be close to it? Of course, just try to make one first estimation, and as we add more readings and more thinking, you'll see that your views might change. And I think this is very useful to happen, and to allow yourselves this time to grow intellectually and to be thinking on your own about how this technology develops. So yeah, that's this chapter, and that's the end of week 1, and we'll be back for week 2.